No reporto.
Alright, so, yes.
Hi, Teuton.
It's right there. Let's start off fairly simple.
I know, I said that yesterday in the recording. You're going to watch it, right? No, he lost it. Yeah, he lost it. He lost the recording?
Yeah, I don't know what happened. I tried uploading it and my computer exploded.
Probably because it was so
I tried using that excuse for homework one time in my teaching it.
Yeah.
One time my dog ate my
Computer.
math. Very small.
Alright.
Like his whole thing.
So, integral from -4 to -1. In your own words, Alan, what is this asking me for?
Integral from -4 to -fx.
Right, yes, that is totally true. I'm given a graph. What does the integral represent graphically?
Area under, and I guess over the curve.
Right, area, no, still under. The curve is up here. Area underneath the curve from -4 to 1. So, Leo, what is the area from -4 to -1?
5. A.
Hey.
Did you say Leo?
I did say Leo. I got like 3 different answers. Alright, let's do another simple one. A little bit more difficult though, because there's a trick in here. Leo. Shh. Alright, integral from -1 all the way up to 4. Thomas, this one's coming at you. Be careful when you say it though, there's one trick. What is the area under the curve from -1 to 4?
No.
Negative b. Right, remember anything below the x-axis is always going to be negative as you're going through there. And think about how I'm asking that. The integral represents what in words?
Area under the curve.
Area underneath the curve. So if I'm saying the area underneath the curve, it's not under the curve right now. It's actually above the curve. So I would need to say it's negative so that my sentence makes sense. That the area under the curve is actually the negative portion, so it truly becomes negative. I'm basically just flipping it over the x-axis to complete the actual sentence and words that I'm saying. Dig? Bless you. Alright, so if that is true, what is this integral?
A minus B.
Right. It would be the total area, and I'm just adding together, so I have A, and then I have a negative B, so this is going to be equal to A minus B. This one?
Oh, you gotta flip them and it becomes a negative and it's
Right.
negative A.
So this one, the thing that's wrong with it is it's working backwards. It's going from -1 to -4. I don't like that. So I need to flip it around, put a negative out front. So this is -4 all the way up to -1 dx. And this one, I do know. The integral from -4 up until -1, that's the area that's going to be A. But I have a negative in front of it, so it's going to be negative A as I'm going through there. Everyone chill with how this happens and what this looks like? Yes? Yes, ma'am?
Should we write that middle part?
Do I say it again?
Should we do that?
You don't have to. Again, in the beginning stages, I'm going to constantly do that so you see very visually what's happening. It's like you asking, when I'm solving this equation, 3x plus 5 is equal to 0. Do you need to write in -5 on both sides? No, I don't care if you do that. But as long as you can trace your train of logic through there, that's fine. Cool? Stranger danger. Talk to you. Alright. One more we're going to look at. This one's going to be the full-blown version of this. Let's go -4, +4 of 3 f of x minus shoot Leo, shut up. Yes. That is okay.
I doubt they'll even watch it.
Wow. Macy, dagger,
They
heart.
have to watch all the teachers.
Yeah, okay. I'm not recording it for them. I'm recording it for you. Oh my goodness. Alright. There's a bunch going on in here. The first business are these things. Right. Anytime. Hey, shh. Too much conversation. Anytime I have a constant. Constants, what do I do with them? Throw it out front. So I have a 3 out front. The integral from -4 to 4. We've already done that one. That's the total thing. So it's going to be 3 times the total area. Make sure that you're putting in parentheses. It's just like normal operations. That 3 multiplies by the entire thing. Then minus. There's something wrong with that right-hand integral. I need to put a negative in front of it, so I have negative. Then I can do the actual integral. So this is -2 times the integral from -1 all the way to 4. What was that integral? Negative b. There's a lot of negatives you need to keep track as you're going through there. So this is 3a minus 3b. The minus minus makes a plus. Positive 2 times negative b, that'll be b. That'll be minus 2b. So my full-blown answer is going to be equal to 3a minus 5b. The negative, so there's a negative right here, yeah? There's a negative because I have to flip my bounds. And then there's a negative in here because the area is negative. Cool? So everyone chill with remembering what this looks like and how I can go from this and use my laws, yes? Alright, well, where this goes wrong is what if I did not tell you the area? It would be a pain in the butt. And we don't know how to deal with that right now. All we know how to deal with is doing some areas that I know and whatever's going on through there. So if I did not tell you that this area was A or this area was B, do you have any geometry that you could use, nice shapes that you could use to find that? Maybe if I had told you that this was a perfect semicircle. How do I know I haven't cut off like the top third of a circle? I don't know. So there's something that we are going to need to use to be able to solve these things. And there's a whole world that we haven't gone into that will help us with this. But before we do that, I need you to live in this world. This relationship, this is the relationship, and I can stem everything back to the previous test on why you failed the previous test. Because of this relationship right here. If I am going from a function to its derivative, what am I doing? What operation am I doing? I'm taking the derivative. Now your problems on the last test were knowing, okay, if I have f prime, I'm going to f double prime, that's the derivative, that's the slope. I need to go from there. If I'm going from f to f double prime, that's the slope of the slope, I need the rate of change of slopes. That's a difficult concept to sort of grasp and wrap your head around. What you need to now know is if I'm going from here backwards. If I am going from f prime to its function, sort of, but we didn't say what the bottom relationship was. Now, I'm telling you that this bottom relationship is the integral. So, going from a derivative to its original function, sort of working backwards, that is an integral. Just as moving forward from a function to its derivative is taking the derivative, if I want to work my way backwards to the original function, I'm going to take the integral. Now, operationally, you don't know what that is right now. All you know is it's the area underneath the curve. That's what tomorrow is. Tomorrow we're going to talk about operationally, mathematically, how you do that process. Yes, sir?
If you knew this on the last test, would it help you?
No. I wrote the test in a way where you didn't need to know that information. And it would not help you in any way. So, this is such an important relationship that we have a fundamental theorem. In fact, it is called the first fundamental theorem.
Hey, Mr. Veenstra.
Yeah.
Do you have a 7th period?
Yes, but I have a data dig today.
You have what?
A meeting.
A date? Okay. What time do you have your class?
Okay. The first fundamental theorem of calculus, V important, thusly named the first fundamental theorem of calculus. What the fundamental theorem says, if I'm integrating from A to B, a function's derivative, bless you. If I'm integrating a function's derivative, that is going to be equal to the function value at B minus the function value at A.
Rate of change.
No.
Sort of, not really.
A child.
So, a child. No, not going to finish it out. So, the integral of a derivative is equal to its function. Now, in this case, because it's a definite integral, I am using the A and the B. And I have to use those as I'm going through there. It won't make sense if I do not. This, very, very important relationship. In fact, it's on your yellow sheet. We'll be adding it shortly. Let's look at an example of this. And we're going to look at graphically first. Because it's calculus, dog. Alright, here's my graph. We're just going to look at the first and fourth quadrants. Going down. Going back up. And then one small blip at the end. We're going to call this intersection x is equal to 0. This intersection x equal to 3. This intersection x is equal to 7. And the final endpoint x is equal to 9. I also know, I'm just going to tell you up front, that this area right here, this area is 4. So this total area in this blip, this area in here is 9.
Wait, but I thought you said we were going to find it.
Baby steps, child. This area over here is 2. So I've got all these areas and I have all these intersections. Last little bit of information I'm going to tell you is that this graph represents the graph of f prime.
Merry Christmas.
Thank you. You just ever have teachers that walk in and give you toilet paper? Neat. Very cool. Thank you, Mr. Bell. So, this is the graph of f prime. Let's find a couple different things. 1. I want you to find, if I told you that f of 3 is equal to 5, I want to find f of 0. F of 3 is equal to 5. Find f of 0. Alright. Again, I'm going to try and ground this in a very logical way. What are you given? What function are you given? You're given the derivative. You are given, stop, shh.
Oh, this is the derivative.
You are given the derivative. What am I trying to find? The function. I'm giving you the derivative. You're trying to find the function. What operation takes me from a derivative into function world? Integral. Okay, so I know I'm going to need to integrate f prime of x. Now, right now we only know definite integrals. So where do you think I'm going to start my integral and where am I going to end it? 0 to 3, because I'm trying to find 0 and I was given 3. Well, we have a way of doing this now. We know that it's going to be equal to the function at whatever this top bound is minus the function at the bottom bound. So it's going to be equal to f of 3 minus f of 0. I'm always going to start by setting up the bits and pieces because I don't want you to try and do it all at once in your head. This is just me setting up an equation based off of the relationship I have in my head, yeah?
Yes.
Now, this BART, again, this is what we have been doing for the past day or so. That represents the area underneath the curve from 0 to 3. Do I know that area?
No, yes.
Wait,
Yeah.
what's the area under the curve of the derivative?
And I have the derivative, and this is the area right there. Yeah. So it's 4. Is equal to, do I know f of 3?
Yes.
It's 5. Do I know f of 0? No, but that's what I'm trying to find. And this is just like a very simple algebra problem. I'm going to move the 5 over. I'm going to divide by -1. So 4 minus 5, I get -1. Divide by the -1 right here. I get f of 0 is equal to what?
I'm confused.
About what?
I got it. Why is f of 3 equal to 5?
Because I told you that right there. That's a given. I'm telling you that's true.
Oh, okay.
Alright, let's do another one with this. I want to find let's find f of 7 now.
Wait, is that still a given?
Yep, that's still given. F of 3.
It's equal to 1, right?
F of 3 is still equal to 5. Alright, so again, the process you need to think in your head. I was given a derivative. I'm trying to find a function. How do I get from a derivative to its function? You integrate. So I'm going to set up an integral. I know the value at 3. I'm trying to find 7, so let me use those two x values. F prime of x dx. Via the first fundamental theorem, I know that that's going to be equal to the actual function at 7 minus the function at 3. Alright, great. Again, Alex, in your own words, what is this front half asking for?
The area underneath this.
Right, the area underneath the derivative curve, which I have, from where to where?
From 3 to 7.
3 to 7. Alright.
That's false. Isn't it supposed to be negative?
Negative,
Well, yeah, that's fine. What would the area in that curve be?
negative 9.
-9. Bless you. Is equal to, do I know f of 7?
No.
No, but that's what I'm trying to find. Do I know f of 3?
Yeah.
Yeah.
So, if I'm trying to find f of 7, so I'm going to have f of 7. If I add 5 on both sides, that's going to be -4. Cool? Alright, this one I want you to try on your own. I want you, not an integral, find f of 9. I want you to try that one on your own. When you get a number, let me know. I'll check you off.
Okay.
f of 9. The function value in the x is 9. Same reason why this total
Oh God.
I have an answer.
But I didn't like identify them. But it was this classroom, I think. But they're like regular tests. And I like somehow I haven't looked at the last time in that like board or whatever. And so I put on the stuff that that's from yeah, the lemonade stand one. It's so weird. It's like no one said anything. So we were all watching
Yes. So, what did you get for this one? -2 is correct. This area should be equal to, this value, -2. Everyone see how that works, yes? Yes. Alright, now let me introduce a little chaos in this. You will need a calculator if you do not have one.
This is my second section.
You want?
I'm going to leave you in the dust. I'm not going to wait for you. Alright. I'm telling you all this business. dy dx is equal to this. I'm telling you y of 2 is equal to this. And I want to find y of 3. Dy dx, don't panic. What is dy dx? Right, this is just the same thing as saying f prime. It's the derivative. So I have a derivative. I have a value. I want to find a value. How do I get from a derivative to its function? I integrate it. So I'm going to integrate this function. What's my lower bounds do you think I'm going to start at? 2, because that's one of my givens. Where do you think I want to end it? 3, because that's what I'm trying to find. So 3x squared plus 4x minus 5. Don't forget your dx at the end. Via the first fundamental theorem, I know that's going to be the function value at 3 minus the function value at 2. Now this one is vastly different from the other one we just did, because I have no idea what this is. What type of function is this inside? Parabola. Do you know how to use squares and anything to find what this is exactly? No, I don't. All you know how to do is either Riemann sums with some subintervals, or what we were doing the other day where we split things up and we'd have to make a perfect shape or perfect shape to do this. Right now, this is some curvilinear thing that I don't know how to do. We will learn how to do this. This is coming. But right now, we don't know how to do this, so you need a trick to be able to do this. Everyone grab your calculator.
Are we going to be able to use calculator itself?
What? On some portions, yes. So, everyone go to math and scroll down to math 9. It says effin int. Int stands for integral. So your calculator knows how to do definite integrals. So you're going to start at 2, go to 3. The inside is your function, 3x squared plus 4x minus 5. What variable am I dealing with? X is, so I put a dx in there and smash enter. So that's saying that the area underneath this curve from 2 to 3 is 24. So 24 is equal to, do I know the y value at 3? No, but that's what I'm trying to find. Minus the y value at 2, do I know that one? Negative 1. So it's really plus 1. To get rid of that plus 1, what am I going to do? So y of 3 is equal to 23. Everyone see how I can do this even if I've not given an actual graph? If I'm just trying to integrate it, great, your calculator can do that. Eventually we will want to be able to do this without the calculator. That's what's coming up next week.
Next week.
You're turning us into calculators.
Wait, what?
Somebody's cooking.
Let's do one more to make sure this sinks in. Here is f prime. F prime is going to be equal to sine of x squared. I'll tell you that f of 1 is equal to 5. I want to find f of, let's go f of 2.
Exponential rule.
Alright, so I'm given a derivative. I'm trying to find its function. What operation is that? Integral. So I know I'm going to need to set up an integral. Where am I going to start my integral? 1, because that's one of the x values I know. Go into 2. The function I'm integrating is sine of x squared. Dx at the end. Make sure you don't forget the dx. Via the first fundamental theorem, because this is the derivative, the integral of the derivative will be equal to its function value, f of 2, minus f at 1. Again, this is all going from f prime going to f. That's the relationship I'm dealing with. Now, again, you have no idea how to do this by hand yet. This is completely out of your realm. And actually, in fact, you will never learn how to do this function by hand. It is impossible. Well, not impossible, but for this class, yes. So again, we're just going to go to our calculator. Math 9. Go from 1 to 2. Sine of x squared. It's a TikTok.
Wait, how do you... Oh my god, I love that song with my cousin.
Dx. Now, let me point out something very important. Everyone look up here. In this problem, it won't make a difference, but for later problems, it might make a huge difference. When you are doing types of problems on the calculator, which we will get more and more calculator active as we go forward, if you get decimals, great. When you are writing the answer, go ahead and round it. 495. But, hey, stop talking. But, when you do your actual calculations, never use this rounded number. Never ever use that. Always in the calculator, scroll up and use the full decimal place. If you start rounding off and you do subsequent calculations, you chopping off that number will turn into something called rounding errors. And it's going to snowball, like a snowball rolling down a hill, into bigger and bigger problems. If you just do one, okay, it might not be that big. But if you do 2 or 3 calculations with a rounded number, your numbers are going to get totally off because you keep rounding them off, rounding them off, rounding them off. Now again, in this case, it's not going to make a difference. But in other problems as we go forward, always use this number here and then go forth and keep doing your calculations. So, this is going to be 0.495 is equal to f of 2, which is I'm trying to find, minus f of 1, which was 5. Add 5 to both sides, so f of 2 is going to be equal to 5.495. Again, in this case, it did not make a difference, but it can. Now, just because Leo said something about it, let me show you the tricks in the calculator for doing this. You can either just go up and click enter and do plus 5. That's fine. You could have done answer plus 5. That would have done that. There is a function that stores things in your calculator. And this is why you have so many different letters and stuff. If I want to keep this number, there's a button down here that says stow. You can click store. It'll come up with an arrow, and you can tell it to store it whatever letter or whatever you want. You can choose a B, you can use a C, whatever. I'm going to use C. So now, in my calculator, anytime I type in C, it's going to return that number to me. If I clear it out, it'll go all the way. So if I want to do 2 times that number, and I want to store it in there, 2 times C, I can get that. So I can store really as many variables as I want in there, up to 27, one for X and one for every single letter in the alphabet that's there. And I can keep recalling them if you don't want to keep on scrolling up and going through there. Dig? Yes, ma'am? For now, it will always be this way. Cool? What? I don't know. Off the top of my head. I don't know. Alright. With our remaining time, I have one I want you to try on your own. Here you go. It's the top one. Top one. Very similar things. Make sure you're paying attention to that graph. You know all the information to do that. See if you can try it. That left-hand side of the graph, what type of shape is that? It's a triangle. You know the area of a triangle, right? 1/2 base times height. The base is 2, the height is 4. So that area from -2 to 0 is 4. You can find the area using geometry of that. How are you going to count half of a block? No, it's not even. It's not even though. The slope of this, it doesn't split the block in half evenly. So you can't say that a half, I don't know what this amount of block is.
So, but like, that's the same as the next one.
Yeah, it's the same as the next one. That's what I was saying.
It won't always be that case. Okay, great, do it.
Do it your way.
I'm trying to teach you the way that will always be. Yes.
Okay. Very tough.